So we are here at AES 2025 with our new friend Russell from Eventide, and tell us about Temperance.
Okay, Temperance is Temperance Pro. We just launched today.
Yep.
We gave a free one out called Temperance Lite. So, if you're not ready for the Pro, go grab the Lite, try it out. But yeah, Temperance is the world's most musical reverb. You can see it's all built around this center control here. And basically we find the notes in the room. We can analyze the reverb space and we know what parts of the room are musical, and we can either turn this temper knob up to emphasize those notes, right? And you can select the notes, right? You can pick which ones you want, or we can turn it down to de-emphasize. So you could do something like turn a percussion or drum track into like an ambient pad. You can sequence that. We have a sequence mode. Or for like mixing tasks, you can do some unmasking in your reverb. If you turn the other way, you want to de-emphasize those notes, make some space for the music that's kind of keep that in scale space going, right?
So, but you can ultimately, what it sounds like is you're saying that you can pick the notes of the key of your song and have your reverb actually play along with it.
The reverb can play along with the notes. The reverb, you can emphasize the notes, you can de-emphasize the notes. There's different reasons you want to do one or the other. You can actually also, if you see this thing here, obviously this is not going to change color because it's just a sign, but you can target the early section of the reverb, the full reverb, or the late section of the reverb for where you want those notes to happen. So not only like what notes, when notes.
So you could have it start at one note and shift into another note?
You could do that with the sequencer.
Okay.
But in this case, when we talk about the early part of the reverb, we're talking about like the very first reflections. Right. So you can have you can basically like get like a really subtle kind of sequence or note sound in the early field, or you can have it kind of bloom shimmery in the late field.
So a tool like this, I clearly can see a use in music production, but would you say that this also has a very big use in something like sound design?
Oh, absolutely.
Yeah.
We don't know yet. We tend to put out the tools.
Yep.
And then people use them in unexpected ways, and we're like, oh, wow, I didn't think of that. It's amazing. So
you said, before we started this interview that you've been over at Eventide for 17 years.
Yes.
So what do you primarily do over there?
I'm the Chief Technology Officer.
Oh, dang, you're the CTO.
I'm the CTO, yeah.
Okay. Hey, so you are kind of you're moving Eventide forward.
Moving it forward, yeah.
Okay, so are products like the H90 and the H9, are those things that you...
Yeah, I did a lot of algorithms and DSP in the H9. The H90 was one I owned. I designed that and led the team to do the H90. It was kind of weird. It was one of the first projects that I completely owned but didn't write any code for. It was strange.
So when did you take on the CTO role then?
That was probably at the tail end of H90.
Okay.
I was working on H90 and split EQ filter design at the same time.
Okay.
I was leading H90 and then still doing signal processing engineering. This is built on something called a modal reverb.
And that's what's on the other side here, right?
No, on the other side, those are our immersive plugins. So we've taken some popular Eventide sounds and made them 3D. Black hole and micro pitch.
Yep.
This is an entirely new way of thinking about reverb in the modal domain, because you can basically we have algorithmic reverbs, which we program and use things like feedback delay networks, and we have convolution reverbs, which we all know about, right? Where you go to a real space and shoot an impulse response, and to us electrical engineers, it's like, oh, that's kind of the basic definition that you can convolve something, but this is something different. This models a room as a series of resonators, like thousands and thousands of filters running in parallel, additively combined to make it sound like maybe a real space, a fake space, it's whatever you want. So we have some machine learning by which we can take impulse responses and turn them into modal responses.
I can see it. I can see it in my brain. So you take the impulse response and then you train the resonators based on that. But since they're resonators, at that point you then have full control over.
We have full control. We know where the notes are.
We know where the notes are based on the pitches.
Yes, exactly.
Fuck yeah. Smart man here. Very smart man. So is this a concept that you developed yourself, or is this a concept that someone on your team?
No. So modal reverb is, any type of resonance-based sort of composition of a space or any sound has been around for a long time. We've known about it academically for a while. One of the interns we hired in 2014, he interned in 2014 and then we hired him. His name is Woody Herman. He's a senior DSP engineer. He's been the one developing this for over 10 years. We're always working on like 5 things at a time. This is one of the things he's been working on. And then him and a whole team of other people have been and then another guy named Corey Karalik led the R&D for the machine learning part of this, like where we can capture these sounds, and Woody did a lot of the synthesis part, like actually realizing them musically.
That's very cool.
Yeah.
Well, thank you so much.
Hey, you're welcome.
So, were you involved in things like the Omnipressor reissue and the H9000 as well?
Not Omnipressor as much, outside of just giving feedback. I'm not really a hardware engineer. H9000, yeah, I probably, over the course of my career, I ported most of our signal processing code to C++. And mostly so we could get it on the H9000, which is running ARM processors.
Okay, very cool. So you not only as the CTO are a visionary of what you guys are trying to push forward, but you can you roll your fucking sleeves up and straight code C++ and get an algorithm going on that box.
Oh yeah. It's actually really easy to write algorithms for that box now. We have a really cool, the team that makes our internal SDKs, really, it's so fun.
Okay.
Yeah.
Very cool. Well, I just want to say thank you so much for your time today.
Yeah, you're welcome.